folks, we're gonna start the panel discussion, and I'm just posting a message to everyone to get your questions ready for our panelists. So we're gonna have a quick, like a short chat with the three of them, and then we'll take questions from the audience. So I'm gonna bring them in one by one. Let's see. Alon, Ben, and Colin. Okay. Right. Um, let's remove that video. So how are the three of you?
Good.
Good.
Yeah, cool. Thanks.
Thanks for patiently waiting, backstage.
Yeah, no worries.
It's a long day. But I think it's gone well. Surprisingly, I was worried about the tech. I wasn't worried about speakers or anything, but the tech I think held up, which is quite good. We have two conferences going on at the same time, so I've been shifting from one to the other. So it's been very interesting. Now we're having the after party for the other one. Okay, so sorry. We're just gonna start with we didn't have any like prepared questions, so I think this is just we're just gonna freeform this. Well, one thing I actually just realized today, when I was looking at your names, is that you're the ABC of WebAssembly. I just realized that today when I was looking at the name. So yeah, so you're not
who's gonna be the D? We're gonna have to find them.
a D, yeah. You complete the alphabet, yeah, definitely. Okay, maybe I'll start with Alon. Alon, you're the co-creator of WebAssembly. Maybe you can share a bit of history, how it got started. Was it part of your job, or was it a side project or something? So that people who are new to this, might get some insight.
Sure, yeah. So WebAssembly started as kind of a joint project between browser vendors around 2014. I think we started the spec process. Ben probably knows the dates better than me. And it kind of came out of previous work on S&JS and native client, other technologies that were trying to get native code on the web in a cross-platform, safe, portable, etc. way. So there was definitely a need for it, and browsers basically joined hands and made it happen around that time.
Yeah, I think my recollection was that it was started in earnest in like 2015, and we had the browser preview in like 2017. And then, sort of a big milestone last year was getting the 1.0 spec. So then 2019. So it seems like kind of a long time, 4 years, but my understanding is that's actually pretty quick for this sort of thing. So we're pretty proud of that.
That's great. Yeah. And Colin, how did you get involved with WebAssembly? I mean, I've known you for a while in the London tech scene.
Yeah.
Because you're very active, like I was active as well. But you were, I think, working on something else, if I'm not mistaken, at the time.
Something else. It's hard to pin down what I was working on because I tend to be doing about 10 things at once. A bit like Aaron's enthusiasm earlier. I'm similar to Aaron, and I guess so many others here, that I bounce around from doing a bit of TypeScript to a bit of D3 to trying to learn Rust reasonably successfully and all sorts of other things. But I first came across WebAssembly, interestingly, through my line of work. I work in financial services, and there was a company that had a fairly bespoke C++ protocol, and they had a number of clients who were saying, yeah, we'd like to use your data in a Node application. And they thought, right, how are we going to do that? And they had already made a start with using Emscripten. So that was my first experience of WebAssembly. But I only did a little bit of it kind of commercially. But the thing that I found quite appealing personally from a pet project perspective is most of the technologies that I tend to use tend to be getting more and more complicated with greater levels of abstraction. I love things like React Native, but the levels of abstraction blow your mind. What I loved about WebAssembly is coming across a new technology that I feel like I can understand all of it. And that's not because I'm like some genius. What I love about it is it's really quite simple. It takes me back to when I first started messing around with computers. You know, it was 8-bit microprocessors, things like the BBC Micro, and you could get the schematics and you could go, I understand the electronics. And that's the thing I found appealing on a personal level with WebAssembly. I felt like I could understand the stack again, which is really unusual these days.
Right. Yeah, that's very interesting. So, what would you say has been like the take up? What's your observation been in terms of like the industry, taking it up? What's like the adoption rate? I know some companies are using adoption, so.
Yeah, I can't personally say how much adoption there is, but I know that we've been working with a lot of partners on it, and I think it's actually kind of what Colin and even Aaron before were saying, is that a lot of people were finding that they were hitting maybe performance limits or something with some of their JavaScript code, and they would pick it up. So if they were using codecs, or maybe if they were doing some sort of video or audio processing, or if they were doing high performance gaming or something like that, they just found that it was like, oh, if we switch to WebAssembly, now we can get a huge performance improvement. And that's not always the case. That's not always the reason that people use it, but that's one of the bigger reasons why we've seen that. So a lot of big tools are starting to experiment with it. We see it in Figma. I think we've seen some of this in Zoom. Like Zoom uses it instead of WebRTC, right? So there's a lot of places where WebAssembly has just sort of been, oh, well, maybe we can integrate just a little part of WebAssembly into our web app and make it into something that works very well for people.
I think one of the challenges when you talk about adoption, typically on the web, when you talk about adoption, people want a percentage. It's an easy thing they can understand. And you can get a percentage if, to a certain extent, you're replacing something with something else. So we used to talk about Flash adoption and Silverlight adoption. You know, it's replacing one thing with the other. WebAssembly isn't really about replacing it. It's about doing things that you couldn't realistically do before. So it's a different kind of adoption that you have to measure. It's more like waiting for these interesting and exciting things to appear because of what you've enabled, rather than a whole-scale move from something else to WebAssembly.
I think that's a very good point. I've actually thought of it sometimes that Wasm is like the video element. It's something new on the web. It's not just making something a little bit faster, but yeah, it's just the new type of content. So just looking at the percentage isn't enough. I agree 100%.
Great. There are actually some questions coming up. Maybe we can take some of the questions for now and then come back to some of the other questions I have. So this one, Colin, sorry, yeah.
Sorry, that's answering a question.
This was your yeah. Maybe we'll still bring it up in case Alon and Ben has got some input. So this is the first question. The C++ compiled to WebAssembly need to be obfuscated to protect intellectual property in your C++ source? That's a long question.
I'm just going to answer that very simply with, if you're thinking about obfuscation to protect your IP on the web, you're thinking about it the wrong way. It's just not possible. I mean, I'm sure the others here can probably provide a more technical answer, but every time I hear about people trying to protect their IP and have a web application, I get a little bit nervous.
Oh, Bennett, you're on mute.
Oh, sorry. Yeah, I'm not an expert here, and but what I found is that, if you give your source code in any form to people, not even source code, the machine code, right? People can reverse engineer it and extract information from it. So it's basically the same on the web. Maybe a little bit easier with WebAssembly because we have designed it to be something that you can sort of take apart and convert into a text format more easily than a normal machine code file. But if you're really concerned about this thing, you have to make sure that you just don't expose that code to people, because otherwise, people can dig in and start extracting information from it.
Yeah, I mean, WebAssembly does. WebAssembly itself is effectively an obfuscation of your C++ code once you've compiled it to WebAssembly. So it does make it harder to reverse engineer, but developers being developers, they love to create tools. There was recently something on the V8 blog about Wasm Decompile, which is a tool that makes it easier to understand decompiled WebAssembly binaries, so making it easier to effectively deobfuscate the code.
It is true, though, that the state of decompilers of native code is probably better. So actually, it's possible that it's more obfuscated as Wasm just because the decompilers are fairly new. But I would say in general, just to add to what others have said, it's about the same as off the web. I mean, when you compile your source code to either Wasm or to x86 or to ARM, it's about the same in terms of the obfuscation of the code. I can't say anything about the legal side because I don't know.
Yeah, and again, I guess very much in summary, you can have something which is more or less obfuscated, but if you've got valuable IP, people will take the time to decompile, deobfuscate, and extract your IP. It's inescapable on the web.
Okay. Next question here is from Aaron, actually, Aaron Turner. His question was, what is everyone's favorite upcoming proposal?
Garbage collection, I think.
I love all my children equally, but no, I do think garbage collection is probably one of the most interesting ones. It's been the longest in coming, and actually it's exciting because it's making a lot of progress right now. So yeah, I'm very, very excited about that one. But I think there are some other really cool ones coming along too. There's some initial thoughts about stack switching, and there's some early experimentation with Wasm 64. So yeah, those are pretty exciting to me too.
Yeah. Again, I'd say garbage collection. And the reason being, I think anything that makes it easier to target WebAssembly from a greater range of languages is a good thing. And I think the garbage collection proposal is probably one of the key proposals that will make it significantly easier for a significant class of languages to compile to WebAssembly.
There's actually a question here. What Wasm 32 versus Wasm 64? We should just mention Ben. Actually, it wasn't really. This is probably more a statement, right, or a request?
Okay. Yeah. No. It's so we've sort of had this idea for a long time, right? WebAssembly, when it was originally created, has 32-bit indices and 32-bit memories, and everything's 32-bit, and that was a good place to start. But we always sort of knew that we would need to do something more than that. And so very recently, I started championing the Wasm 64 proposal, and colleague Wouter has been working pretty hard to get it, and he has it actually implemented in LLVM and some of the other tools. And so we're really looking forward to being able to actually use it for real. And I think the big benefit here is that for a lot of developers, they don't really want to have to deal with 32-bit builds. Like, it's 2020. There's 64-bit architectures nearly everywhere. So why not Wasm? And I think this is a really good opportunity to allow us to expand into that same space.
Okay, got another question.
So Ben, can I just ask a question? I'm struggling to work out the technical details on that one. With Wasm 64, what will that practically allow us to do in the future? Does that make it easier for WebAssembly to run on 64-bit architectures, or is it something I'm a little bit confused by this one?
Yeah. Let me go into more detail. So Wasm already can run on 64-bit architectures.
Yeah.
Right. So the Wasm 32 is really just a question of like how big can your memory be? And so
it's addressing, right? Okay.
Yeah, exactly. So your pointers right now, and we don't really have pointers in WebAssembly, but the equivalent is a memory index, and the index is 32-bit, so it can only be up to 4 gigabytes. So the question is, how do you extend that? And the solution is actually hopefully very simple, which is, well, we have memories that have 64-bit indices now, and we have new instructions that allow you to access up to 64 bits.
Right.
So it doesn't exactly work the same as a normal 64-bit architecture in the sense that you don't get virtual memory. So the question is, how does that change the way people write programs? If you're assuming that you have 64-bit address space that you can just use willy-nilly, you won't get that. And so that's kind of, it remains to be seen whether that's an issue. But for now, the idea is really just to be able to access more than 4 gigabytes of memory.
I see. So you're going to want this or need this if you're using WebAssembly in a context where you need a significant amount of memory. If you're re-implementing Fortnite, for example, or doing data processing, but not if you're trying to squeeze it onto a microcontroller.
Yeah, probably not on the microcontrollers. They're already upset about Wasm 32. I think they want Wasm 16, to be honest.
Cool. Thanks for that.
Yeah.
Okay, bringing up another question. Can you outline ideas regarding GC support for languages compiling to WebAssembly? Is that anyone want to?
Not exactly
I
sure how
can
to parse it. Sorry.
Well, I'm guessing are they wanting to gain an understanding of what it means and how it's going to be implemented. I can certainly do it on a high level. The guys over that way know it in a much more detail. But from my understanding, I mean, one of the challenges with compiling a garbage collected language to WebAssembly is it doesn't have a built-in garbage collector. So the technique that is often used is to create a garbage collector and compile that to WebAssembly. So you've almost got an emulation of a garbage collector running within WebAssembly. I'm pretty sure that's how AssemblyScript does it. So from what I understand, the garbage collector proposal doesn't add a garbage collector to WebAssembly itself. However, it allows it to integrate with the host garbage collector. So it's a fairly lightweight way of permitting garbage collection of objects that are sitting within linear memory. Now, hopefully I'm not going to get corrected for that.
Yeah, it's almost actually. So that's actually one of the biggest questions is how exactly do you create to enable garbage collected languages in WebAssembly? And there are a range of solutions, one of which is sort of what you described, right? Maybe there are objects that live in linear memory and then can integrate with the host garbage collector that exists. So in the web platform, we already have a garbage collector. We actually have multiple garbage collectors probably. So it would be better to integrate with the host's garbage collector. But as you mentioned, a lot of programming languages maybe want to compile their own garbage collector in. So the primary garbage collection proposal that we have now leans more towards integrating with the host garbage collector. In the future, we may experiment with trying to figure out how to make it easier for a WebAssembly module to write its own garbage collector, but we're focusing mostly on the host integration side right now. So that's kind of where it's at. And what it ends up meaning is like now you can define the shapes of your objects inside of WebAssembly, and then you can create new objects, and then you can do things with them, modify the fields of the objects and cast them to other objects and so on. And then most of the complexity is what is the right design there? What shapes of objects should we allow? That sort of thing. So yeah, there's a lot of complexity. If you're interested in sort of diving into more of the details, I would definitely suggest checking out the GC repo in the WebAssembly GitHub.
Great. Okay, question. Would an iOS app abandoning with runtime violate? I'm not sure if you can answer this. Violate App Store rules, so you would be able to run apps in your app.
Oh dear, that's a can of worms, isn't it? I think it violates App Store rules if they decide it violates App Store rules. I believe there's a certain flexibility to the interpretation of those rules based on Apple's business model at the time.
But you can ship it as a website and let them access it using the browser. That wouldn't have any limitations.
Yeah, because it's not an app.
Yes.
Yeah, definitely cannot speak for Apple or iOS or anything like that. But my understanding is that they do have the JavaScript engine that you can interact with in your app, right? And so if you use the WebAssembly engine inside the JavaScript, inside JavaScript core, to run your WebAssembly and you communicate with that one, maybe that's okay.
I think the thing that I've seen with Apple is that a lot of their rules are designed around protecting their business model with respect to purchasing through the App Store and in-app payments. So generally, you fall foul of their rules if you're trying to use some other payment subscription system or some other way to avoid using in-app purchases and so on. So it's less about the technologies, it's more about what those technologies allow you to do, and that's what gets you into trouble with Apple.
Controversial. Okay, next question. How about scanning the stack for pointers? Does that make sense?
Yeah, so there is a stack scanning proposal just starting up now, and that eventually I think will provide this functionality. Today there's another option. There's a tool called Asyncify that can let you actually instrument the WASM. It adds a little bit of overhead, but after that you can actually literally scan the stack for all the contents. So it is possible today with overhead, and hopefully in the future will be possible very efficiently and nicely.
Okay, moving on. When can we expect better support on the tooling front? Example, Debugger.
Could probably answer that because I'm working on it. So I don't have a specific date or anything, but we are working on this very hard, as you can see if you just look on the open source repos in LVM and Emscripten and Binaryen. And so there's a lot of progress. No specific dates again, but it is getting close, is my feeling.
Just out of interest, what's the current approach that you're taking? By Debugger, I'm assuming they want to breakpoint their code, inspect variables, and so on. And I know currently with the likes of AssemblyScript and others, they use source maps, so you get a certain amount of debugging support. The last time I tried with AssemblyScript, you could add a breakpoint and you could step through your code. However, your local variables were highly obfuscated. They were the current variables within your WebAssembly module, so they were all integers and so on, rather than the variables within your AssemblyScript code. So are you progressing along the source maps route, or are there other options being explored?
Yes, so what we're focused on now is on the dwarf style of debug info. So dwarf basically embeds a large amount of data about the locals so that you can actually recreate the source locals and the source stack and everything. So it is a lot more work, but it does allow things that source maps don't, which I just said have pretty big limitations. So once we get there with dwarf, you will be able to do all the things that you can do today in a debugger normally, but you'll just be using the browser's debugger to do it, and it'll just handle the dwarf for you.
So at the moment, will your Chrome DevTools, for example, will they support that once you've formalized the specification and implemented it within WebAssembly, or will the Chrome DevTools also need to be modified? Because as you said, this isn't source maps, this is a different approach.
Yeah, so we are working with the DevTools people. So there's work on the spec, both on sort of the DevTools side and the protocols. And yeah, it involves certainly all the components. Right. They all need to work in tandem. So it is quite a lot of work.
Yeah, it'll be a huge benefit, definitely.
Actually, one cool element of that is, rather than having to rewrite a lot of the dwarf understanding of dwarf in DevTools, you can potentially, and I think this is the plan, maybe Alon can correct me, but to use a WebAssembly module inside DevTools to help understand the dwarf so that you can display it to the user. So
is this just your cunning plan to get WebAssembly into Chrome?
One step at a time.
And then slowly Chrome will entirely be implemented in WebAssembly.
That's a nice dream. But yes, I mean, we can use a lot of code in this case by compiling an implementation of the dwarf spec. Dwarf is a large, complicated spec that you don't really want to write an implementation from scratch generally. Yep. So yeah, as Ben said, the part of the plan is to just use a Wasm module that contains the compiled dwarf stuff.
WebAssembly is the answer to everything.
Indeed.
Okay, next question. What's the status and set of challenges around introducing threads to WebAssembly?
Again, I'll do the usual thing of providing the high level and then pass it over to the experts for the details. So I've had a go with multi-threaded WebAssembly maybe a year or so ago. So I don't know the status whether it's behind flags or whatever else, but you already have sort of I forget the terminology, but the ability to perform atomic operations. So in other words, you can do things like increment an integer in a thread-safe fashion. So at the moment, you can create a WebAssembly module, and you can create a number of web workers that execute with a shared linear memory and perform atomic operations on top of it. That gives you some sort of low-level constructs that allow you to create multi-threaded applications. I don't know whether the person asking the question is asking for effectively native support of threads within WebAssembly rather than tools to allow you to operate within a multi-threaded environment. I don't know whether that's on the roadmap. I mean, is that something that's likely to come in the future? The ability to be able to spawn a thread from within WebAssembly.
Yeah, I think it's we'd like to do that. I mean, we've talked about sort of a Threads v2 for a long time. Exactly how that will work is complex because, especially in the web platform, there are sort of constraints that make it very difficult to do anything more than sort of work with web workers. And so, as soon as you have the things that are not inside the main thread, everything gets more complicated. And that's one of the biggest the problems. And so the question is, if you have your own sort of native Wasm thread, what actually can that do? And how do you limit its functionality so that it doesn't try to call imports that it doesn't have access to, for example? And so, yeah, the design space there is pretty complicated. And that's partially also what makes it just difficult to use threads currently. But I don't know. I mean, I think Alon can speak to it. Emscripten does a lot of the heavy lifting here by providing a pthreads implementation that hopes to sort of paper over a lot of the complexities in the web space.
Yeah, so we do provide the pthreads API, and it's shipped in stable Chrome and in Firefox, so it is pretty widely available now. Most basic usage of atomics and pthreads will just work out of the box. So actually this is pretty usable today on the web. However, as Ben said, there are some limits there because of how the web platform works. And therefore we would like, I think, to add some sort of threading inside Wasm itself. That would also probably help with getting threads to WASI and other places. So I think that in the long term could be a good solution. But you can actually use it in most cases on the web today already, and actually also in Node, where we use Node workers to emulate web workers. So it's usable, but we'll get better.
Now, in order to use it in the web and to have multiple threads operating on the same linear memory, you need shared array buffers. I can't recall. Our shared, I know that that was withdrawn at very short notice due to Spectre and so on. Are they back again? I've not checked for a while. Are they readily available and usable?
Yes. So in Chrome and in Firefox, they have shipped. There are some limitations that I admit I don't understand fully with the co-op stuff. That there's some header stuff that maybe Ben can say. But in general, if you set up the web server properly, it does just work. That is, it has reshipped after the initial Spectre.
Cool
stuff.
Yeah, the details are complex to me, but the basic idea is that you sort of your web server has to request, like, I'd like to be isolated from all other origins, and if the browser says yes, I've isolated you, then what you know is that there's no other sites that are inside your process. This is sort of the high level way of thinking about it, which means that now it should be safe to create shared array buffers and share things between threads, because there's no one else can be sort of like snooping on your data. Again, like the very high level description of the idea there.
Okay, we've got another question here. Any tips or upcoming tools for decreasing WebAssembly module size? module size seems to be a very like in topic moment. I see a lot of discussions on Twitter regarding this.
Don't use Blazor. No, I don't know.
So, I mean, I think in general, I mean, there are a lot of tools, tips that are specific to the tools. So I mean, it's sort of a big question that we could talk about a lot. But in general, I mean, each language will have some patterns that are more efficient for code size. There are also some general tips like using the Binaryen optimizer, Wasm opt, which typically will shrink a Wasm by about 10 to 20%. But yeah, most of the issues are language specific, so it's hard to get too much into it. I gave a talk about this earlier in the year, which is online, I think. You can maybe check that out for some of the language details.
Yeah, I guess my joke was, to a certain extent, partly a joke and a serious point. A lot of it is down to the language specific and how much of a runtime they have to ship alongside it. So AssemblyScript has got a pretty lightweight runtime that ships as part of the WebAssembly module, whereas Blazor is on the far end of the spectrum in that it has a sizable runtime that ships. So yeah, there definitely isn't a single solution for this.
And yeah, there are definitely big trade-offs. Oh, sorry.
Sorry about that. Yeah. I was going to say, yeah, so it really does depend now. There's not maybe a lot of great solutions, but one thing that I'm actually very interested in exploring from the spec side is like, are there things that we can add to WebAssembly to make it easier for people to shrink modules? And so, you know, for a long time, we've been talking about this layer 1 compression, right? So WebAssembly, you can think of as being layer 0. It's just got this binary format. And then layer 2, we always talked about as being something like gzip or Brotli, like taking your WebAssembly and shrinking it so that it can be shipped over the network and smaller. But layer 1 would be something in the middle, right? Like if we had a compressor that knows about the structure of WebAssembly and can be clever about it, then perhaps you can do better than something like gzip or Brotli that doesn't know any of the structure. It's just looking at the raw bytes. So just looking at your WebAssembly files, you'll find some pretty obvious stuff like local get 0 is one of the most common instructions in virtually every binary. And, you know, obviously that's just 1 extra byte. You could reduce it to 1 instruction and you could save maybe like 400K. gzip will probably already catch that, but you can imagine other sorts of things like that where we could potentially use the structure of the WebAssembly to shrink things down a little bit better. So that's one thing that I'd like to explore in the future.
It has, I guess this is mostly about taking a WebAssembly module in isolation and shrinking that, whereas looking at the way it works with broader web technologies, the process of shrinking is quite complicated these days, involving typically bundling together a whole load of different modules and tree shaking, and then should we be bundling with HTTP2 and so on? What's your thoughts around WebAssembly module size, and will it change if we start creating WebAssembly applications which are a little bit more like traditional web applications that are composed of a large number of WebAssembly modules?
That's a good, very, very good question. Naively, you would hope that with WebAssembly, you could sort of link them and then use all the static info to get rid of unused code in a very efficient way, potentially better than JavaScript can. However, we see this constantly in the Binaryen optimizer. The main thing we keep hitting is this issue of indirect calls, which every time you see one of those, it could go almost anywhere. So I do see that as you start to build up larger apps, and it's probably if you start to combine things, as you said, Colin, you probably would run into this issue. I have some hope that we can improve this if we could annotate indirect calls using multiple tables and using sort of the indirect call info that I believe LVM has at some level that it can use for security reasons, but I've not had time. But this is one of the things I would love to see progress on, because if we could eliminate indirect calls to any amount, we could probably shrink a lot of code at the moment and in the future as applications grow.
Yeah,
to that point, is there any way that people from the community can help progress some of these things, or is it down to a few people? Really?
No, I mean, yeah, definitely we would love to get help. Concretely about this, I think it would need to start with something on the LVM side. I don't understand enough how they track indirect calls and they reason about them in LTO, but if there's someone that knows about that or has time to learn about it, that would be a good place to start. The other side of it is I believe it would depend on having multiple tables. So each table would represent kind of a type of pointer. And I'm not sure offhand what the status of that proposal is. Maybe Ben knows.
Multiple tables comes with the reference types proposal, the extern ref proposal. So very close to being standardized.
And so almost referencing back to Aaron's talk, another way that people in the community can help is whilst it's quite challenging probably to get involved in the actual development of WebAssembly itself, but it's not, the doors are not closed. But another way to help with something like this is to just push WebAssembly to its limits, build start creating more complex and challenging applications, because that will really inform the decisions that are made around these sorts of issues. So similar to Aaron in his talk, creating Wasm Boy, which really pushed assembly scripts to its limits.
Yeah, and actually, to your point, I think we found a number of users who have done things where they've found that in their app they have code that's hot and code that's cold, and they've understood that if they can split that code into two modules, then that's another way that you can maybe not easily, but you can reduce the module size. So making that sort of thing much more easier for users to do, I think that would be great too. And that's really mostly a tooling thing.
Yeah, so you're thinking of things like lazy loading. Yeah, code split.
Okay, one more question here. Actually, two more. Is there a lot of consideration of the off-browser environment use cases, and what are the potential opportunities and trade-offs in that space? Who wants to answer it?
Again, I can sort of chip in with the general. I mean, one of the things I do is I publish a WebAssembly weekly newsletter, although it's a bit of a lie because I don't manage to get it done in a week. But one of the things that anyone who's involved with WebAssembly has noticed is just how much interest there's been in this language and this runtime for non-browser based applications. We've heard of some of them today, but I think the big ones that keep cropping up again and again are on the server side for sort of serverless classes of application, blockchain. So as a smart contract execution engine, we're seeing it crop up all over the place. A question to you guys: do you think the name was a mistake? Are people starting to regret it?
What's in a name?
Yeah, I mean the logo's great anyway. It looks like it looks like a chip. That's good.
Yeah, I think the use cases is an interesting question to me, because from a standardization point, it really does show this kind of maybe a split in the goals. Like if you are running inside a web browser, I mean, a web browser is practically an operating system, right? And so you really want WebAssembly to be able to tap into that functionality that is already there. And if you're running off browser, then there's a good chance that, like, for example, if you're doing something like Lucid, you want to probably have as minimal of a runtime as possible, I would imagine. Just something that you can just get up and running very quickly, and maybe all the logic that you need is already inside your module. And so I think that's an interesting place where we might see divergence in the directions that people want to push WebAssembly. My view is it would be great if we could do both, but I think it will be hard, and it would be great to have more people involved here. But yeah, I think the off-browser case is still very vibrant. There are a lot of people working in this space, so I'm pretty excited about that.
And in general, I've got a feeling that WebAssembly as a technology will find greater success outside of the browser than it will inside of the browser. I don't know whether you'd agree with that.
I mean, it's hard to say how you would measure it, by the percentage. I mean, it's hard to say.
Well, within the browser, I always see WebAssembly as occupying some important yet somewhat niche use cases, whereas outside of the browser, it can be front and center in some quite conventional applications. You know, if it's being used as the execution engine for smart contracts on the blockchain, you know, WebAssembly is front and center rather than occupying more of a niche within a wider ecosystem.
That's a fair point, I think. I do hope, though, that WebAssembly will become less niche with GC, but it remains to be seen, I guess. But yeah, that is a good point, that it is more front and center and those other use cases.
So by being, I agree that well, it makes it a lot easier to compile a wider range of languages to WebAssembly if you have garbage collector. What use cases do you think that will bring within the browser specifically?
Well, I mean, I would hope to see large applications that consider it as a language. I mean, you have websites being written in TypeScript and Reason and other languages today that compile to JavaScript. My hope is that with Wasm CG, that'll become another option in that space, and therefore we could see major sites use it. I mean, obviously there's a lot we need to solve, but I think it's a possibility.
I see. So you think in the future there's a chance that you might see sort of, I don't know, e-commerce sites where much of the site is written in Rust?
Well, I would actually, so the C++ and Rust style languages that use linear memory are maybe not best suited for this. Yeah, I mean, I do think that those are, I mean, they'll always have an important place in the Wasm ecosystem, even on the web. I mean, especially on the web, both on and off. But GC languages have the potential to reach, I think, a larger percentage of websites, which doesn't necessarily mean that they're more important or less, as we were saying earlier. But I think the GC languages just integrate better with a web platform. They're friendlier to developers. So it's possible they'll become wider.
I see. So more like things like Ruby or Python, where people are already doing things like Ruby on Rails in the back end. They might want to use Ruby to do their front end.
Possibly, yeah. Yeah, exactly.
I'm actually excited for the possibilities of something like, well, like AssemblyScript, right? Where it's a new language that maybe uses some of the functionality of WebAssembly very directly for GC. I think that'll be pretty cool.
I've always thought in the future, if you could just take an existing JavaScript application and just flick a switch and it would compile to WebAssembly, everyone would be using it.
AssemblyScript is the closest that you can get, probably.
Exactly, and it's still quite a long way off when you take a vanilla JavaScript application and compare it to AssemblyScript, but the gap is going to keep closing, and the adoption of TypeScript is increasing significantly. So the closer AssemblyScript can get to TypeScript, the more that becomes, you know, a possibility.
Sorry.
Just to add to that about AssemblyScript, I think it has another benefit in that it is designed for WebAssembly. So, I mean, I do expect people will use Python and Lua and Ruby, etc., just because they like it. But they will always need to bundle some amount of runtime, I expect. AssemblyScript has the potential to be really maximally efficient once we have Wasm CG and they can connect to web APIs, etc. That I think is really exciting.
Yeah.
Okay, I think we're gonna have to wrap up in a little while. But I just have one question. I think it's really for Alon. But if Ben and Colin, you've got some insights as well, just add to it. I think you wrote something about this, if I'm not mistaken, because I've seen so many tweets. With the recent layoffs from Mozilla, I mean, how is that impacting the work on WebAssembly right now? Is it impacting it or not really, or?
I mean, it's hard to say. I mean, I don't know that I have anything concrete to add, but just maybe to summarize what I said there. I mean, obviously, I assume this will have some impact, but but I get the sense that a lot of the people affected are finding jobs in other parts of the WASM ecosystem, so I'm not very worried. And also, these are successful open source projects with vibrant ecosystems, so I don't think there's any concern. I haven't felt any change. Maybe other people can comment.
I guess WebAssembly, Microsoft, Mozilla, Apple, you know, they were all involved with the development of WebAssembly, weren't they?
Yeah, it was never a single company.
Yeah.
Yeah.
It's the way it works on the web.
Yeah, I mean, we definitely have continued to see our Mozillian friends, or ex-Mozillian friends, show up in various communities and stuff. So, yeah, I think WebAssembly is still going along great.
That's great. It's great to hear. Yeah, and I actually we're talking to some people, and they're feeling about the WebAssembly community is it's very friendly and supportive. I hope that's really the case, and I hope if that's the case that it continues to be that way. So how would people get involved more with the community? Do they just attend the weekly meetings, or what's the best way to to get involved? Ben, that's probably a question for you. Oh, you're on mute. You're on mute, Ben.
Yeah, sorry about that. Yeah, I have a few suggestions about how to get involved. If you're just sort of interested in following along with things, you can read the meeting notes. Those are in the WebAssembly/meetings repo. And maybe comment on issues in the repo there. If you want to chat with people, there's a WebAssembly Discord, which I'm sure you can find a link to if you search for it. And a lot of people from the community are in there and chatting. That's a great resource. If you want to come to the meetings, you can do so as well. They're usually pretty technical, but you can also just hang out and listen to what's going on. And that can be pretty good way to do it too. If you'd like to contribute, there are tools. So obviously Binaryen that Alon works on. There's Wabbit that I work on. There's LVM, which is a huge project, but also got a lot of really cool stuff in there that you could work on there too. And it's Emscripten. So yeah, there's a number of projects you can work on. I don't know if other people want to add on to this list.
I was just going to say, I had no idea it was pronounced Wabbit. That's cool. I guess to sort of broaden on that point, you asked about joining the WebAssembly community, and I guess the community is bigger than just the core team that are pushing WebAssembly itself forwards. Again, referencing back to the talk that Aaron did, Assembly Script itself is a sub-community which is really quite vibrant, and there are many more, lots of them clustered around particular languages.
I think there are like meetup groups, right, popping up around WebAssembly. I know there's one in San Francisco, and there's one in Europe, and apparently there's one in London. And I actually just inherited that group today. The person who designed the website, sorry, not the website, sorry, the logo, the winning logo for WebAssembly, started it. I don't know if Carlos was his name. He's consulting with Bloomberg right now, but he's so busy. So he said, are you interested in running it? So I'm going to be running it. So we'll see how that goes. I need to learn more about assembly. Obviously, I'm good with the running part, but I need to be more familiar with the technical side of it, I guess. Which is actually, I'm. It's a good challenge for me as well, because what I noticed is there's not a lot of women, in this community right now. Because I was looking for a lot more women, speakers, but yeah, I approached some, but they're busy, but there's not a lot of choices basically. So I'm challenged by that a little bit. So hopefully we'll get some support from you folks. And yeah, thank you very much for joining us. I think we need to wrap up. I think it's been a good conference, and thank you everyone for joining. And hopefully we'll see you at another WebAssembly Live. Hopefully we can do an in-person one. whenever that can happen, and we can bring back some of these wonderful speakers and panelists. Thanks, Alon, Ben, and Colin, the ABC. Sorry, that's ABC of WebAssembly. That's your new group name. And yes, so I hope you enjoyed it as well.
Cool. Thank you.
Thank you.
Thank you very much.
Yeah, thanks a lot.